Welcome back to the third and final part of this year's workshop. We will now conduct a small parameter study on an additive manufactured model, and after that I will give a short wrap-up. But first, let's have a look at the results. After the effective stiffness computation has finished, the result viewer opens, and we can see the Young's modulus of the isotropic approximation and the Poisson ratio, and also the shear modulus, Lame's modulus, and bulk modulus. If we scroll down for the orthotropic approximation, we see that the Young's modulus in x, y, and z direction are almost the same, which means that the structure is isotropic, which coincides with the results from before, where also the pore orientation was found to be isotropic. And further down in the results, we get a transverse isotropic approximation and also the full anisotropic elasticity tensor. We can also have a look at the strain stress visualization by loading the strain stress result file. We can select the stress field by double-clicking the von Mises stress. And again, we can threshold to see the strains and stresses larger or smaller than a certain value. For the last part, we are now going to execute a parameter study. At first, we are starting the macro that the parameter study is running while we set up the study. For that, you can, in the top right, select a different workspace. We select the second workspace and click it, and we now have a blank desktop again. Here, we double-click the Geodik 2023 icon and wait for it to start. We are again in the workshop project folder, and now we are starting the parameter study. For that, we select macro, execute macro script. We now click browse, and we go one folder upwards, and we go to the workshop digital material R&D folder and go to part 3. Here you can find 2 macros. Select the macro strut-based lattice parameter study and click open. We select vary and now parameters. For the near node strut diameter, we enter 0.25, comma 0.5, comma 0.75. We can copy that and also enter that for the center of strut diameter. This means the parameter study will be conducted for the near node strut diameter and the center of strut diameter with 3 different values. 3 times 3 makes 9 total simulations. As I said, a very small parameter study. We click OK. We select the silent mode and we click Run. Now, while this parameter study is run, we go back to our Geodik folder and we now start a macro recording. We click macro and select start macro recording. As a file name, I just select parameter study and click OK. Now, the first thing this study should do is make a project folder. For that, we right-click on this project folder and we say select project folder. And we can say new folder and we can name it parameter study. Now we need to create a structure. For that, we head back to model, grid geo, and we select the strut-based lattices. We click edit. We change it back to one periodic copy. We click OK. And now we just click the record button. Do not click the run and record button, but only the record button. This will record the settings from this GridGeo app run, but only recorded in the macro file. As a next step, we go to Predict, select ElastoDict, and click Edit. We adapt the result file name to enter mode. One periodic copy. As the settings, we choose the same settings as before. So we click OK, and again, we only click on record. Now the macro recording is done, and we can select macro and end macro recording. We can now go to the workshop project folder, or you can click on Application, File Manager, select Geodict, my first Geodict project folder, workshop project folder, and in here you can now find the macro, which is called parameterstudy.py. We click right-click and open with text editor. The first thing we do is we take care of the variables. For that, we take this section, we copy it, and we paste it below because we want to have two variables. We change the number of variables to 2, and now we have to uncomment this thing. This means we delete this hash and enter 2 spaces. Again, we will do that for all in front of those variables. We need to give the variables a name. We name the first variable near node diameter. And as a label, we just give the label near node diameter. The type is double and the unit is millimeters. For this case, we do not need a tooltip. As built-in default, we select 0.2, and we also do not need a check. Now we need to change this 1 to a 2. It seems the parameter study just finished. And as a name, we select center of strut diameter. The label again is center of strut diameter. The type is double, the unit is millimeters. No tooltip. Built-in default 0.4. And also no check is needed. And take care to remove also this small comma. Now we go down to the change project folder. We select create if not present and change it to true. Next, this is the execution of the structure generation. We now need to make the file name be changed for each generation. For that, we introduce an F in front of this string. And at the end, we add an underscore NND for near node diameter, curly bracket open, and we enter the variable name, near node diameter. We close the curly bracket, we hit underscore, center of strut diameter, curly bracket open, and we close the curly bracket. It's important that you use the same names as at the top with the same case, upper or lower case. Now we copy this near node diameter and introduce it instead of the 0.2 in line 81. We also copied this center of strut variable name and introduce it in line 82. Now, if the case study is conducted, the macro uses the variable near node diameter and center of strut and writes it in the result file name and uses it for the structure generation at that point. Also for the elastic stiffness, we need to set a fitting result file name. So we enter an F at the beginning and an underscore behind the copy. And again, we enter an NND for near node diameter, curly bracket open, near node diameter, curly bracket closed. Center of strut, curly bracket open. We hit Control S to save our changes, and with that, our parameter study is able to run. So let's head back to the other Geodict with a parameter study. We can click Application, File Manager. We select Geodict, my first Geodict project, Workshop project folder. We can now find the results of the parameter study in the parameter study folder. Here we have the GDR files and the corresponding result folders. For that case, the visualization script, which has a look at the results and makes quick plots out of those GDRs of the elastic properties. For that, we select the minimal visual evaluation file and we click Run. After we click Run, the script grabs the ElastoDict results and calculates plots and displays those plots in the result folder. The plots are evaluating the center of strut diameter over the isotropic Young's modulus, the Poisson ratio, the shear modulus, and the solid volume percentage. The same is also done for the near node diameter, and also the solid volume percentage is compared to the isotropic Young's modulus, to the Poisson ratio, to the shear modulus. Let's have a look at the influence of the center of strut diameter and the Young's modulus. By double-clicking this picture, we can see the center of strut diameter depending on the near node diameter. And we can see that with increasing center of strut diameter, also the Young's modulus increases, which is to be expected. Also with increasing near node diameter, also the Young's modulus increases. But it seems that the near node diameter has a larger influence on the Young's modulus compared to the center of strut diameter. Similarly, we can see that the Poisson ratio decreases if either the near node diameter or the center of strut diameter increases. Having a look at the near node diameter compared to the isotropic Young's modulus, we can see that if the near node diameter increases, also the isotropic Young's modulus increases. Similar, if the center of strut diameter increases, also the Young's modulus increases. Finally, looking at the solid volume percentage compared to the isotropic Young's modulus, here we also have the center of strut diameter and the near node diameter independently plotted. So we can see that if the solid volume percentage increases, also the Young's modulus increases, or for this line, or for this line. So this gives us a rough idea that the near node diameter and the center of strut diameter, if both are increasing, so does the solid volume percentage, and if the solid volume percentage increases, also the Young's modulus increases. But it seems that the near node diameter has a larger influence on the Young's modulus compared to the center of strut diameter. Now, with the parameter study finished, we are ready for a short summary of the workshop. In part 1, we tackled the modeling of the structures. In part 2, we did the analysis. In part 3, we used the combined knowledge from part 1 and 2 to set up a parameter study. More specifically, the structure model for additive manufacturing part 1 also lets you know how to set the project folder, safe and load structures, how to create strut-based lattices, and what different models of strut-based lattices there are, and how to create triply periodic minimal surfaces, and what different kind of triply periodic minimal surfaces there are. In part 2, where the property prediction of additive manufacture was tackled, we calculated pore size distributions, we had a deeper look at more specific settings for pore identification, and we calculated conductive properties as the heat and the electrical conductivity. We calculated diffusivity properties, the diffusion coefficient, and the tortuosity factor. We also calculated permeability by doing a fluid flow simulation, and we calculate effective elastic properties by using the ElastoDict module. In part 3, we did a small parameter study on an additive manufacture model, which enabled you to set up a GeoPython macro recording, to introduce new variables to this GeoPython macro, how to execute GeoPython macros, and how to start a Mirai Geodict Python macro execution. Thank you for your attention, and I'm happy to get your questions and suggestions. Goodbye, everyone.